Yes. Hey, hey, hey. Welcome back. Now let us solve the problem sorted insert for circular linked list. So what does the problem tell? We're given a sorted circular linked list, and the task is to insert a new node in such a way that the circular list remains a sorted circular linked list. So what does that mean? Yeah. So we are given an element. Let's take two. So to insert two in such a way that the link between four and one is not broken, and the link list is circular. And consider this element. So you again you take five inserted in such a way that the circular link between 9 and 1 is not broken. And it is guaranteed that 5 has been inserted between 4 and 7. So how can you do this? Yeah, this is like pretty straightforward itself. So you will just keep track of all the elements, and if you find by the instant you encounter a circular link list, like instant you encounter a cycle, that means that you can break off and you can add the data, which is by that time guaranteed to be the biggest element in the linked list. So you will add that data element to the last of the linked list, and then you'll connect the last of the linked list to the head, I think. Yeah, like to wherever it was pointing, not head, but like wherever it was pointing. And yeah, that is there are only two edge cases. The first edge case is when the node has to be inserted in the beginning. The second edge case is when node has to be inserted at the end. And it is very easy to insert any node in the middle of the linked list. So what we'll do for now, first we will just take care of inserting in the beginning and the end, like inserting in the middle and then. That is very easy. So what you have to do? So first of all, you will have a current folder pointing to head. And so since we have to keep track of where a cycle has existed, we can use the Floyd-Warshall algorithm for finding the cycle in the linked list. Or what we can do is we can also have a dictionary and not have any elements in it. And as soon as we encounter any node, we'll just put it in the dictionary. This will increase the time complexity from O1 to OK. But first, let us solve the problem, and then we'll think of decreasing the time, decreasing the time complexity. So what we'll do, and while the curve exists, you have to always also keep track of previous, because what we'll do is that we'll check if 4 is greater than 2. As soon as we see that 4 is greater than 2, we will take this 2 and insert it before 4. So we'll have a previous pointer which is currently pointing to none. And what we'll do, while cur exists, if by any chance cur dot data will become greater than data, cur dot data, that means that the node has to be inserted in the previous position. So what you will do, first we'll create the node with value data, and previous dot next will be pointing to node, and node dot next will be pointing to cur, and then you can directly return head. Or else what will happen if the by any chance if car exists in dictionary, that means that you encountered a cycle, so we will break out of it, because the node has to be definitely inserted at the end. Or else what we'll do, we'll update our pointer, so 3 will become cur and cur will be cur will become cur dot next. So now what we'll do is, by any chance, let's just test it on some custom input. The first line contains, which is denoting the linked list. The first and the last node are connected. Okay. Given that the very important point to note is that the connection is always between the first and the last node. So that actually makes this question a lot easier. So we'll have 3, 4, 5, 6, 7, and we have to add a node called 3. So this should work. Let us just see. Yeah. So so now what we have done is that whatever we do, anything which is less than 6 will always work. Like anything which has to be inserted in any place except the beginning or the end will work. But as soon as you try to insert in the end, yeah, uh, as soon as you try to insert anything in the end or in the beginning, so the beginning, currently this approach will not work. So the only two edge cases are left. So now what we will do, we will handle those. So first of all, let us handle inserting at the end. So by now it is guaranteed that our node the data which has to be inserted is greater than any element present in our linked list. So the data has to be inserted then. So we'll create a node, and what you will do, again 3.next you will point it to node, and node.next we will point it to curve. Yeah, again we did the same thing over here. In other words, we just, yeah, like we have to do the same thing again. We have to create a new node. We have to take the prev.next and point it to our current node. And you have to take the current node.next and point it to our current pointer. This will ensure that you are updating the linked list properly. So I'll return head for now. And let's go to custom input. And yeah, now let's just check if we can insert at the end. And yeah, insertion at the end is also done. The only thing, yeah, and you have to do one more thing. This is the reason. If by any chance the cur exists in the web break, but what we are doing is that we are not adding our cur to our dictionary. So get the position cur is equal to 1. Yeah. We forgot to add our current pointer to our dictionary. That is why it was yelling. And yeah, now you see that it is guaranteed that any node which has been inserted at the end will also work. So now what you have to do, you have to take care of the instance where the node has to be inserted in the beginning. That is very easy. So you will do if head.data is actually greater than data, that means that the node has to be inserted in the beginning. So first we'll create the node as as node.data. But there is one thing which we have to be careful, and that is the fact that our last node is actually pointing to our first node. So we can't actually directly modify our first node. What we have to do, we have to take the first node's data, like the heads.data, and we'll actually put it in a new node. And what we will do, we'll and now what we have to do, we have to take the head.data and modify it with the data which we already have to insert it. This ensures that our what has happened now is that imagine you have to insert 0 over here. So this one has been replaced with 0. And 4 is pointing 0. Like always what we have to do, if we like directly link 0 to 1, then you have to take care of pointing 4 to 0 also. But better than that, what we can do is that we can actually replace the data in our current head node with the data to be inserted and create a new node with the data which the head node has. And then what we will do, yeah, that is just draw it out. Okay, okay, that is very bad drawing. So let's have good circles. Yeah, I'm not Leonardo da Vinci, so it will happen. So let's have data over there. So we have 1, 2, and 3 over here. Okay, let's make it 2, 3, and 4 over here. So there is connection like this, there is connection like this, and there is connection like this, and we have to insert 1. So what we will do, yeah, and so we have to insert 1. So what we will do, first we will erase the data over here, and we will make it 1. So this ensures that the connection between 4 and 1 is removed, just is resolved. And what we'll do, we will remove 1 dot next, and we will actually take a new node and insert the data of the current head node also. So this will actually become 2. And we'll take 1 node depth and point it to 2, and we'll take 2 node depth and point it to 3. So this ensures that the connection between 1 and 4 also exists. So we don't have to again go manually and change it. And it ensures that the connection is made from 1 to 2, 2 to 3 also. And yeah, we are basically doing that itself here. So what we'll do, node is equal to node with head dot data. Head dot data is equal to data. And we'll have a pointer pointing to next node also, because we need to keep track of that. Head dot next. And now what we will do, so now carefully think again what has to be done. So we'll take head and we'll take the next value of head and point it to our node. And we'll take node dot next and we'll point it to our next. Like we'll point it to our next and we'll return head. So we just did these connections and we chained it. So now let us just do a custom input and let us check it for one. I put hide somewhere over here. HEAD. Any hide left? I don't think so. And yeah, it's working. So yeah, let's just submit it once. And as you see, this works, and this has time complexity of O of n because we have to traverse the internet, and space complexity of O of n because we are keeping a dictionary which has like every data in the list, but like if you see expected state complexity is open, and it is guaranteed that head node is always connected to a tail node. So like tail node is always connected to a head node, so we'll use that to our advantage. So what we do, we'll just add head over here with the value 1. So now if you try to compile and run it, like it will not work. Like let's make sure that we're adding some in between value, and you see it does not work. Why? Because we have already added a head over here. So what do you have to do? Cur can't be pointing to it. Cur has to point to head dot next, because head is already present in the dictionary and we don't need to check it. And if it was to be inserted in the first position, that has been done on top. This is point to head. And yeah, with this much modifications, I think the algorithm will work. And yeah, so now what we can do is that we can actually remove this line also. Since it is guaranteed that our head is always connected to our, it is guaranteed that our tail is connected to our head, we can actually not add any more elements to the dictionary. This will ensure that our time complexity is always open. So this what we can do is, if you don't want to use dictionary, we can have T1 pointing to head, and if by any chance, we can actually remove this also. If by any chance cur becomes equals to T1, we can break out, and let's just submit. Let's just submit it once. And yeah, as I said, this approach also works. You just have to ensure that you're keeping track of the current head. Yeah, and this is like truly one space, because we are not even using any dictionary to keep track of our one node. And yeah, that's all for it. And thanks for watching, and goodbye.